Hi, this is Mrs. LaBarbara. This is Physics Chapter 6, Momentum and its Conservation Video 2. Today's topic is the real-world applications of momentum impulse theorem. The objectives are to understand the effect of collision time upon the force and the effect of rebounding upon the velocity change in force, and also effect of collision time on velocity change. First, the relationship between collision time and force. So how is force and collision time related? As you can see from this equation, when you multiply the two quantities, that means they are inverse. Two quantities equals to constant, they are inversely related. Let's take a look at this this picture. This is boxing. When you ride the punch, you extend time. Therefore, your force is smaller, because the change in momentum is constant. But when you don't ride a punch, the force is bigger because time is small. The bigger the time means little force, and little time means bigger force. So the greater the time over which the collision occurs, the smaller the force acting upon the object. To minimize the effect of force, one must extend the time. Similarly, the opposite is true. To maximize the effect of force, one must decrease the time. This to maximize the force. Sometimes that's what we want to do, like karate chop. If you want to do karate chop, nobody does it slowly. You have to do it very quickly to minimize the time. Therefore, to maximize the force. Here are some examples of reducing force by increasing time. Airbag. Airbag is used in automobiles because they can minimize the effect of force by extending the time. The mats used by gymnasts. A boxer riding the punch. Nylon ropes. Nylon ropes have elasticity. It can extend, it can be stretched. And by stretching it, you extend the time of falling, therefore to minimize the effect of force. Next one, let's talk about the effect of rebound. Rebound is to bouncing off each other. So rebound involves the changing the direction of object. So rebound are characterized by large velocity change, large momentum change, large impulse, large force, and large acceleration. Rebound has the bigger delta V. So when this increases, the whole change in momentum increase, the impulse increase, force increase. Here is a picture of rebound. In case A, car goes to the wall, rebound. In this case, in case A, the velocity change is 9 meters per second. Case B, there is no rebound. The velocity change is 5 meters per second. Large velocity change results in large momentum change. So during collision, we don't want a rebound to happen, because when rebound happens, we have large velocity change, large momentum change, we have large force, there's large damage. Rebound and automobile accidents. So in order to reduce the rebound, we have all the cars are built with crumple zones in the front and in the back. What does crumple zones do? The automobiles are made with crumple zones. Crumple zones minimize the effect of force in an automobile collision in two ways. First, to limit rebound, and therefore to minimize momentum change and the impulse. Second is to lengthen the time, therefore reducing the force of impact. Sometimes we want to increase velocity, such as when you hit a baseball. Right? In racket or bat sports, hitters are often encouraged to follow through when striking a ball. Why do you follow through? When you follow through, you increase this time. By increasing this time, since force and mass could be constant, so you increase the change velocity, you increase the final velocity. So in this situation, both the force applied as hard as you can and the mass of the ball are constant. By following through, the hitter increases the time. The result is increasing the ball's velocity. Let's take a look at some examples. A constant force can act on an object for different length of time. As the length of time increases, the impulse, I hope you can do it, it's increasing. This is because the impulse equals force times delta t. When delta t increases, J increase, because J and delta t are directly related. If delta t increases, what happens to momentum change? Momentum change will also increase because momentum change equals to impulse. Momentum change equals to force times delta t. As delta t increases, delta p also increases because delta p and delta t are directly related. Again, effect of time on speed. A cannonball shot from long barrel cannon travels faster than the one shot from short barrel cannon because the cannonball receives a greater force impulse, both A and B, or neither A nor B. Let's see, this is the effect of time. The difference between long barrel and short barrel is long barrel receive the same force for a longer period of time. So both long barrel and short barrel have the same force. Long barrel has longer time, short barrel has a shorter time. Since long barrel has longer time, so therefore it receives a bigger impulse, and that bigger impulse result large velocity change. Okay, so here is cannonball shot from a cannon receive the same force regardless of the length of its barrel. Long barrel will take a longer time for the cannon to travel since J equals F times delta T. Delta T increases, delta V increase. A student drops 2 eggs of equal mass simultaneously from the same height. Egg A lands on the tile floor and breaks. Egg B lands intact without bouncing on a foam pad lying on the floor. Compared to the magnitude of the impulse on egg A as it lands, the magnitude of the impulse on egg B as it lands is the same. So you probably have say, really? Then why the egg B breaks, not egg why egg A breaks, not egg B? Well, egg B did not break because its force on egg B is less than the force on egg A. The force on egg B is less because time for the egg to the impact time is longer because it's a foam padding. To extend the time, therefore reduce the force. But the impulse is the same because change in momentum is the same. They are the same. They are all dropped from the same height. Before both eggs touches the floor, they have the same speed. Then that speed all comes to rest. So you have change velocity is the same, and it's the same mass. The 2 eggs have the same mass. Therefore, change in momentum is the same. Therefore, impulse is the same. But again, egg B did not break because egg B has a longer impact time. Another example, a 0.5 kilogram cart is pulled with 1 Newton force for 1 second. Another 0.5 cart is pulled with 2 newtons for 0.5 seconds. Which car has greatest acceleration? Explain. Well, car 2 has greatest acceleration. Why is that? It's according to Newton's law. Newton's law says acceleration is net force divided by mass. And as you can see, cart A has acceleration of 2, cart 1 has acceleration of 2, cart 2 has acceleration of 4. Which cart has greatest impulse? Well, the impulse is the same. That's because the impulse equals to force times time. 1 times 1 equals to 1. 2 times 0.5 is also 1. So they have the same impulse. Which cart has greatest change in momentum? Well, change in momentum is the same because the impulse is the same. Change in momentum equals the impulse. Therefore, they are the same. Another example. So 2 cars of the same mass are traveling down Lake Avenue with the same velocity. They both comes to a stop over different length of time. Here's the ticker tape patterns of each car shown on the diagram below. Which car experienced greatest acceleration? Well, acceleration equals the change velocity over time. And for car A, the time is shorter than car B. Therefore, acceleration is bigger for car A. Question B, which car, A or B, experienced greatest change in momentum? Well, change in momentum is mass times change velocity. Mass are the same, change velocity are the same, so they have the same change in momentum. Which car experienced greatest impulse? Well, impulse equals to change in momentum. Therefore, they have the same impulse. That's it for today. Thanks for watching. See you next time.